All right, today we're going to look at confidence intervals for the difference of two proportions. Please remember that you want to have your formula sheet and a calculator for sure at the minimum. We learned back in chapter 8 that a confidence interval had two parts. It had your statistic and it had plus or minus your margin of error. Well, to calculate your margin of error, we needed to know the standard error. And so what is the standard error for our new distribution, p hat 1 minus p hat 2? And how is this different from the standard deviation? And why is this different than the standard error we use for significance tests? So that's what we're going to talk about now. I'm going to actually answer number 2 before I write down the standard error formula. Remember, your standard error is an estimate of the standard deviation that is calculated using your sample data. Remember, the standard deviation is calculated using your true proportion, which we don't know, because if we knew our true proportion, there'd be no reason to write a confidence interval estimating our true proportion. So our standard error is basically your standard deviation, but using your sample data instead of your populations data. So if we go here to our formula sheet for two sample proportions, you see it even nice and lovely has a title that says standard error of the sample statistic. Well, right here is the standard error for the sample statistic for confidence intervals. Now I'll go ahead and answer that third question while I'm looking at this formula sheet. Remember when we did a significance test, we used these pooled proportions instead of P1 and P2, P hat 1 and P hat 2. So when you're doing a confidence interval, you do not use the pooled proportions. You use that blue formula for your standard error. So your standard error is going to be are you not writing? Okay. So your standard error is going to be the square root of p hat 1 times 1 minus p hat 1 divided by your first sample size plus p hat 2 times 1 minus p hat 2 divided by your second sample size. So we use the pooled proportion when running a test for proportions. We use each samples parameter when creating a confidence interval. So the formula sheet has, you're going to use this for confidence interval. You can use this for means, for tests. Whoops. But we also, just to remind you, we did talk about that second formula and how that is the exact same as the formula that I have circled in blue with the substitution of P, the pooled proportion, instead of each individual samples proportion. Okay. So what is the formula for a two-sample Z interval for P1 minus P2, and is this on the formula sheet? So back to your formula sheet. We don't have an official formula on your formula sheet for your confidence interval. We just have these words. That is your statistic plus or minus your critical value times the standard error of your statistic. So the statistic for proportions, the symbol is, I'm getting ready to do a test. Let's do an interval. So the statistic is p hat 1 minus p hat 2 plus or minus your critical value. So that's Z star times the square root of, remember this is your standard error, p hat 1, 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. So that is the specific formula for a two-sample Z interval. So what are the conditions for calculating a two-sample Z interval? And these are in your textbook. I forgot to notate where they are. I'll write that in later. But if you go to section 10.1, you could find it in your textbook. But here are the 3 conditions for creating a confidence interval for proportions. And if you'll notice, they are the exact same as they were for creating a significance test or calculating a significance test. So let's do an example. Have opinions changed about gun control? Gallup regularly asks random samples of U.S. adults their opinion on a variety of issues. In a poll of 1,011 U.S. adults in January of 2013, 38% responded that they were dissatisfied with the nation's gun laws and policies and want them to be stricter. In a similar poll of 1,011 adults in January of 2012, a year earlier, only 25% agreed with this statement. Explain why we should use a confidence interval to estimate the change in opinion rather than just saying that the percentage increased by 13 points. Do me a favor, press pause and see if you can come up with an explanation before I give you mine. Okay, so the reason we want to use a confidence interval is these are just estimates of the true proportion. We don't know for sure what the true proportion is. Remember, we have a lot of variation from sample to sample. So just knowing this sample versus that sample, these are just estimations. We do not know the actual truth about how the population feels. So let's write a confidence interval. Use these results to construct and interpret a 90% confidence interval for the change in the proportion of U.S. adults who would agree with this statement about gun laws. All right, so we are going to do all of the fun 4 steps. Let's do our state step. Again, we want to estimate the true change in proportion of all U.S. adults who would agree with that statement. And we were told to do the 90% level. So we're going to let P1 be from 2013. We're going to let P2 be from 2012. All right, plan. Check our conditions. This is not an experiment, so we do need to think about a simple random sample. So we have a simple random sample from both populations. Check. Let's check our independence condition. We are going to be checking the 10% condition here because we are sampling without replacement. So is 1,011 less than or equal to 1/10 of the U.S. adults in 2013 and the same sample size. And we need to check if that's less than or equal to 1/10 of U.S. adults in 2012. I think I forgot to put up here, when I say the true change, we're going to take the first population and subtract the second population to get the complete true change of populations. So I think these are both true remember, if we multiply 10 times 10, 11, that is definitely going to be greater than the, or less than the number of U.S. adults in both 2013 and 2012. So our independence condition has been checked. All right, let's check our normal condition. So our normal condition is where we look at the successes and the failures and make sure they are all greater than or equal to 10. Okay, so our normal condition, we had 1,011, and our first proportion was 0.38, so 38% in 2013. It gives me 384.18. And 10, 11, 1 minus 38.62. That gives me 626.82. And let's check for the second sample. This time in 2012, it was 25%. And that gives you 252.75. And 10,011, 1 minus 25%, 0.75, is going to be 758.25. And these are all larger than 10. So our normal condition has been met. All right, our do step. Now, yes, we are going to be able to do this in our calculator, but I want to do it by hand first because remember, your AP exam is probably going to want to see you set it up. They don't care if you can press a bunch of buttons on a calculator. They want to see that you can set up the confidence interval and basically show what the calculator would do. So we're going to do this first by hand, and then we're going to go in and check it with our calculator, and we're going to talk about the difference between the two and all that good stuff. All right. So remember, our confidence interval from our formula sheet is our statistic plus or minus the critical value times the standard error of the statistic. All right, so the statistic here is going to be p hat 1 minus p hat 2. So 0.38 minus 0.25 plus or minus z star. All right, so z star, we have a couple options. We can use our calculator, but that is painful. We can go find z star on our formula sheet. If you go to table B, the T table, and if you go all the way to the very last row of the T table, see where it says infinity? This last row these are all Z stars. So we're doing 90%. So our Z star for 90% is 0.1645. Times the standard error. So that's that big old square root thing. 0.38 times 0.62 over first sample size. All right, and our second successes, 0.25, or second proportions, 75 over sample size. All right, so if you'll pause for just a second and see if you can type that in your calculator and you can get this interval. All right, let's conclude. Oops. We are 90% confident that the interval from .0963 to 0.163. Remember, you can write those as percentages if you want to, like 9.63 to 16.3. Captures the true change in proportion of all U.S. adults who agree with the statement about gun laws. All right, so that is your significance test by hand. So let's go back up here and let's look at this confidence interval and let's calculate the confidence interval in our calculator. So let's go to our calculator, stat, over to test. We are doing a 2-sample Z interval for proportions. So let's go find that one. A 2-sample Z interval right here. Now, we're going to learn what a 2-sample T interval is later. So a 2-sample Z interval, that's number 9. Again, we can use data or statistics. We have the statistics. Wait, I did that wrong again. We're going to talk about all these things once we learn them all. I need to find the 2 prop Z interval because we're doing a 2 proportion Z interval. So I need to do B enter. All right, our first number of successes. Now, if you'll remember, this is going to come from these numbers right here, 384.18 and 252.75. But remember, when we're using our calculator, we have to round according to the rounding rules. So our first successes, it was 384.18, so 384. And our first sample size was 1011. All right, our X2, it was 252.75, so we're going to round that to 253. And then 1011. Our confidence level is 0.90. And calculate. So you can see that the interval is 0.09592 to 0.16323. All right, so let's go back here. And if we use our calculator, we got 0.09592 to 0.16323. So you can see that they're a little different, and that's only because of round off error, because we clearly rounded off some things when we were calculating the interval by hand. So again, that's why it is very important that if you plan to use the calculator and not write out all of that stuff, which in a normal year would be perfectly acceptable, we need to be sure we name the inference method. So this is a 2-sample Z interval for proportions. So if you're going to use the calculator, you want to make sure that you have down the name of your inference method. You don't need to write all that down because you've written that down somewhere on your paper already when you were checking the conditions. All right, so we're 90% confident that the interval from 9.6% to 16.3% will capture the true change in the proportion of adults who agree with that statement about gun laws. So based on the interval, so going back to the last chapter where we can actually use a confidence interval to give the results of a significance test, is there convincing evidence that opinions about gun control have changed? Think about it. Yes. Why? We need to look for 0, since 0 is not in the interval. So if you'll remember, your interval was 0.097 to 0.164. So since 0 is not in that interval, we have convincing evidence that opinions have changed. Remember, your confidence interval gives you all plausible values at a 90% confidence level. It gives us plausible values of the true change in opinions or true change in proportion of people who agree with that statement. And since 0 is not in there, that means 0 is not a plausible value. So 0 would mean that the two proportions were equal. And that means there was no change. Therefore, since 0 is not in the interval, we do have evidence that opinions have changed. All right, thanks for being here.